This one just shows basically what would happen if you melt various amounts of ice. It's about 65 meters worth of ice up on the Antarctic continent, of which only about 5 meters is grounded below sea level, and so is of potential worry. Greenland has some areas grounded below sea level too, and has a potential for about 6.5 meters of sea level. So that there's some potential for raising sea level a rather dramatic amount over a few hundred years if these theories are correct. And that perhaps is the issue that is the long-term issue of most concern. Well, I said earlier that I didn't think there was any realistic way of preventing the CO2 increase if we continue to use fossil fuel. One might ask whether there's any way of preventing the climatic effects as opposed to trying to adapt to them. There have been a number of suggestions that one go around injecting stratospheric aerosol, sulfur into the stratosphere, and create more aerosol to reflect back the additional solar radiation that you would be capturing. It turns out economically it's not that impossible a kind of suggestion. The question is all the side effects you have, and you start managing the climate in a real sense, and is that something you really want to get into? You may be able to alter the surface albedo to reflect additional radiation to space in various ways. Or you may try and take some actions in some way of preserving the polar ice and not letting it melt back. As I said, these effects that occur are sort of a mixed blessing potentially, and some of the agricultural things. A big help would be to reduce the rate of increase of CO2 concentration, basically because that slows the rate of climate change. Society is able to adapt reasonably well and has in the past to relatively slow climate changes. It's when they occur rapidly, as for example one goes into a dust bowl situation, which is sort of what's projected if you, as CO2 sort of warms, and that's sort of what's projected for the middle US by some people. If it happens slowly, you could probably adapt. If it doesn't happen slowly, you're probably in trouble. The short-term issue that's probably of most concern in this case is water. Particularly water in agricultural areas and in the West out here where we are. In fact, in California, an issue. The Department of Energy program started 4 or 5 years ago with a financial base of maybe $400,000 or $500,000 per year. It grew through last year at a doubling each year and was up to something like 12 million last year. I'm sorry, this year it's at 12 million. It was supposed to be at 14 million. It did not suffer major cutbacks in the first phase of the Reagan cutbacks. Next year it's projected at 8 million, however, so it's getting its turn. It has basically 6 major themes that it pursues. The direct effects of CO2 on vegetation, carbon cycle research, so projecting the future CO2 concentrations, climate modeling, first detection of CO2 effects, the effects of warming on the Antarctic ice cap, which is a program that it hasn't figured out how to do, but it wants to get into. It realizes it's necessary, but it turns out almost any money you put into an Antarctic research program goes to the Navy for fuel costs to get the people there, not into science. And then the 6th one is everything else, indirect effects, everything else, effects on agriculture and vegetation. They had the AAAS preparing a major program plan in that area that included agricultural effects and social effects and economic effects, but the present administration has basically cut that way down, so the Department of Energy shouldn't be doing economic and social research. Yes?
Interested in your amplified polar temperatures in some particular parts of the geologic graph, I think specifically the Cretaceous, and I think the Eocene, you had circumpolar alligators. Has anybody looked at this with respect to the vegetation types at the time and the possible carbon dioxide effects with this particular model?
Well, no, the three-dimensional models that most people focus on with the CO2 problem take hours to run a year, and so they tend not to run back very far. The simpler climate models that take seconds or minutes to run a year, people have tried to explain how you could have warmer polar regions. It's going to be it's an interesting question, and it is not resolved. right now you get heat transport from low latitudes to high latitudes because there is a relatively large temperature gradient. If you reduce, and that energy is needed to warm the high latitudes, even though they're still pretty cold. If you increase the temperature in high latitudes, you lose that temperature gradient, and so it's not clear why you'd get heat transport from low latitudes to high latitudes. So it's hard to understand how it can be that warm, even though there's good evidence that it was. People have looked at a lot of processes and haven't worked it out very well. It's probably related to the positions of continents and how well the oceans can transport heat up there, partly, and partly to how much CO2 existed in the world. And I think there's some Russians who have interpreted some geological evidence that the Cretaceous had much more CO2, 2 to 3 or 4 times as much CO2. And one may be able to do it that way. Not clear. Yes?
What about the timeline between when you put CO2 in the atmosphere and when it really starts warming? This one is like 20 years, or is that each year that you do it, or are there working estimates out so 20 years down the line?
Well, no, it's probably something like 20 years. And that's because it takes time for the oceans to warm and for them to increase their evaporation into the atmosphere, and for that whole cycle to go on. And so basically we've made a commitment now about some more heating for 20 years, even if you held CO2 constant. That's one of the problems, and that's something that hasn't been well treated in these attempts to identify climatic change yet. Yes?
I didn't understand the effect of the water infiltrating the ice shelf, getting underneath. What is the ultimate effect of that as the water seeps in?
Well, it basically weakens the structure of it. It transports enough heat in, and I guess there's enough mechanical motions and everything that the shelf that is sitting on it just will calve away, and you'll get a gradual warming of the shelf because you can get warmer water in underneath than exists there, and you can just gradually calve it away. It's basically, I think, a mechanical issue. The strength of the ice sheet just cannot sustain sitting out on the ocean water. I don't seem to have answered your question, I guess.
So you're suggesting that the ice fractures might fracture, but it will still float?
It will still float, and then it will float off out into the Antarctic Ocean where it will melt. Yes.
It would be transported ultimately out of the ice shelf.
Yes.
Is that likely? Considering the way you drew the profile, it seems to decline, the elevation declines as you go inward. It didn't seem highly likely that that ice could float up and over into the ocean.
Well, that was sort of a schematic diagram. The ice is pinned on a number of mountains that sort of hold it in place, but there are some passages between it, so that it turns out there are, when you do simple modeling, it looks like it's going to go. When you start looking at all the complications of it really having to happen, you're not so sure. But certainly, ice sheets calving back like that is an occurrence that's observed. It's occurring up in Port of Valdez right now. There's a major ice sheet that comes down in there that has come to a ridge that has protected the ice sheet from water getting in underneath, and it's calving back, and they're expecting it to go, I don't know, miles per year or something like that back as it calves off, and they're worried about the icebergs and the oil tankers and things. Yes? I guess I'm going to beg off on that question. I'm not sure I feel competent to answer the question. I don't think the salinity changes much. I don't think that's an issue. pH of the ocean changes about half a unit, which may be an issue. Yes?
If I were going to do my part, would I plant a conifer or a deciduous tree?
Well, I guess what you want is the I don't know. It's hard. That's what I ask. The more you can store, the better, I guess. And that depends on where you are. Yeah. Right.
If the ocean were to rise 6 meters, by what percentage would the land surface area be diminished?
60 meters? Well, Well, yeah, no, let me make clear. The fraction that can melt, and the projections are basically 5 meters is what they're looking at. The rest tends to be grounded on land, and the assumption is it will stay there, okay, that you won't melt that. And so you have to deal with sort of with 5 meters. Now, in some regions, that's pretty severe. If you're in Florida, you're in big trouble. I mean, you're going to lose half of the state or something like that. I don't know what's regular. And if you're down along the Texas coast and some of the Caribbean coast and stuff, if you're on the coast of California, it's not going to be all that much of a problem. Some of the social questions they wanted to get into studying were how you respond to that. Walter Cronkite opened his universe show on CO2 by standing on the dikes of Holland. And the typical response is to build your dikes higher and higher and higher, because that is the least expensive thing to do on an incremental basis. However, once you get a catastrophe, you're going to be in big trouble. Then you have to relocate all at once, and that'll be very, very expensive.